this video, in the next couple, we want to go over the pH of salt solutions. And what's important to realize up in the overlay here is that if an acid reacts with water, it can form an anion that is its conjugate base. And that anion can be part of a salt, and the question is does that interact with water to form hydroxide? Likewise, if a base reacts with water, it can form a cation, and that cation could potentially protonate water. That is, the cation is the conjugate acid of a base. Now what we need to recognize, and I'm just going to write this for the acid, is I have an acid, and that reacts with water. And it forms hydronium plus the conjugate base of that acid. So this is the acid, this is its conjugate base. If it's a strong acid, the equilibria goes all the way, and this does not interact with water. If it's a weak acid, then there's an equilibria, and both this and this coexist. And if it's a weak acid, the A- will react with H2O to form the weak acid plus hydroxide. That is, it pulls a proton off of the water. Okay? Now what we want to look at right now are the salts of a strong base and a strong acid. Such a salt could be NaCl. We know that if I took NaOH plus HCl, this is a strong base, this is a strong acid, this would form NaCl plus H2O. Now if I look at the reaction here for HCl, HCl is a strong acid. That means it goes all the way, forming H plus Cl minus. Realize you don't have an H plus, you're really donating a proton to water, and it's hydronium, but we often omit the water here and implicitly draw it in the H plus, so this is really H3O plus. And this reaction does not go this way. So Cl minus plus H2O is no reaction. Now I could have NaOH. NaOH is a strong base. That means it goes in this direction, and this does not interact with water. So Na plus H2O is no reaction. Okay? Therefore, the pH of a strong acid and a strong base is 7 because none of the conjugates, the conjugate base of the acid or the conjugate acid of the base, interact with water. In the next video, we'll look at a weak acid or a weak base, and we'll see how that does interact with water.